please allow me to introduce Dr. Schmidt to you. She is going to, Teresa, she is going to do this chocolate. There we go. That's better.
I went on and made you 2 handouts. No, keep 2. One you can write on and one, okay, I'm not used to being this loud. Okay, so I can probably do it without the microphone. I'm that loud. One for you to write on and one for you to take back if you want to ever use this little activity again. And so what we're going to do, since y'all been talking about fermentation and wine and beer, and I'll drink any milk you put in front of me except buttermilk. That's an oxymoron, butter and milk. Ugh. So this is your bushels of grapes. And we're going to model how this process, when you think about it, and Tony can get more into this than I can, about how the process, I guess I need a cup and a plate myself to model this with to get them started, because I'm not going to do this completely by myself. So think of this as you've harvested your grapes, and you're going to, it takes a while for the fermentation process to break the grapes down into vinegar, wine, juice, whatever you want to make out of it. So the first thing that we're going to do, if you look at your handout, is you're going to have to count the number in your bag. We need to know how many bushels of grapes your vines produced this semester. Now, before you panic and you think, oh my God, I can't use M&Ms in my classroom, you can use Skittles. If that bothers you, you can also use Kraft caramels that are wrapped, and they have a K and the word Kraft on them, and you can tell the kids, well, when the K shows up. And if you're really non-foodie, use integer chips. Y'all know what I'm talking about, where it's red and yellow on one side? Use the same thing. Just have the kids reach in and grab a handful of integer chips. It becomes random. Now, do you think before we get started that everybody's going to have the same number of bushels in their set?
No.
No.
Why?
By weight.
So by weight. So some kid's got to holler, I got cheated, I only got 60, and somebody's going to say, well, I got 150. So just letting you know. So the first thing you need to do is just pour them out on your paper plate. If you don't want to use paper plates, you can use just plain old piece of paper, whatever's clean. And I'm not going to do this again because I did it last night. You got to count your M&Ms. So come up with some method for counting your M&Ms. They don't have to be sorted by color or anything, you know, so. Okay, so I'm going to have to randomize because I don't want to like do this again. When you get down through here, it's talking about shake and pour out. The first thing we need to know is how many M&Ms, that is times 0, how many you have in your bag. So I'll just ask, it looks like you are.
I have 102.
You have 102.
100.
100.
101.
101.
103.
103. 102.
103.
103. So they're really good. I know y'all had Dr. Lisa Green yesterday. Did she talk to you at all about statistical variation? Okay, this is another thing about statistical variation. If you're looking at the manufacturer, they want to make sure that we've had who had the lowest? 100? The highest is 103. So statistically, their equipment is very accurate on weight. Okay, because it's really close. So I'm going to use the average line. I'm going to say right here, I'm going to put 102. You use your sample. Okay. Can y'all see that, or do I need to zoom it in a little? Because I don't know. So everybody's okay with that? There's a little spot right here where you can write 102. or 103. No, you do whatever. Okay, now I'm too far in. Okay, there's a little place up here in the reading. You got to get them counted first. Okay, now put them back in your cup if you hadn't figured that part out. All right. Now, some mathematical things about M&Ms. They are the perfect mathematical candy. They are perfect little circles. They are also perfect ellipses if you turn them sideways. And Dr. Martin was telling me yesterday there was some more math that you can do with this. There's a whole book on M&M math if you're interested. It goes all the way down to 3rd grade. You can use it all the way through college, and I use this occasionally in my college classes. Okay, so there's 2 sides to your M&Ms, one with an M and one with a blank side. If you have a broken M&M or one that you don't think is really good, you can eat it already. It's just reduce your number of sets, okay? But you're gonna shake it. So I'm gonna slide this off to the side. You're gonna shake it. And any of the M&Ms, and the yellows are really hard to see, I know that already. Any one that is showing with an M, you're gonna have to discard. And then you count the ones that remain. Now, so this is your initial bushels. All right, so there's a big handout page on the 2nd page here. So up here, this is times 0, so we had about 102. Whatever yours is, you use your number. On your first, literally, on your first roll here, subtract out all the M's, pull them to the side. You can actually eat them if you're hungry. Okay, they're gone. They have turned into wine or whatever you want to call it, vinegar at this point, I would guess. You know, they're not completely degenerated yet. When you get all your M's out, and be careful with your yellows, because like I said, they are really hard to see. Now you recount the ones that remain. So I'm going to wait till y'all get them. It takes a few minutes. The one thing I will recommend is do not use the mini M&Ms with these. If one, you can't see them, the kids can't see them, and they tend to be more circular, and they roll everywhere. Yeah. Peanut M&Ms, they're not as perfectly circular, and they don't have a flat side. When you think you've got them all removed, of the M's removed, then count the ones that remain in the plate. And I see some of you putting them in your cup, so I'm going to give you a second. Yeah, I'm going to give you a second cup. Some of you are doing that. If you want to discard your, I'm not sure I've got enough for everybody, but if you want to, because you'll need a shake cup. The ones that are on your plate with no M's, that's time 1. How many bushels have not decayed? Okay, so if you want to take your M&Ms that you're discarding and put them off to the side and use another shake cup, okay? Wow, yours fermented fast. No, M is the ones that are gone. They have turned into, so what you're doing here is the ones that remain on your plate is what goes here. That's a good, excellent question. The N, did I answer that right? It's the ones that remain on the plate. So ever how many of these that have no M's? Like we have one down here, man, she's fermenting fast. I mean, her process, I don't know what she put in her process, but I'm telling you, she's gonna make it to the market. So these are the ones that you count, and these are the ones that go back in the shake cup and you do it again. And you keep doing it. That's why I didn't know, because it could be just one show up with an M on it. You keep doing that until either all of them have disappeared or you start getting a constant number. Sometimes that happens because it's random. You can also do this in statistics. So what was some of the average numbers for N1? Because I'm going to need some canned data here.
51.
51,
I had 59.
59. How many? I can't read name tags, I'm sorry. I'm the
I have
world's
53.
worst.
I had
53.
I had 58.
60, so
73.
I'm gonna say, boy, you blew it. Now I'm gonna have to 70 plus 51 divided by 2. Okay, I'm gonna say I had 61 in my sample. This is how, as the teacher, you get by without having to do the experiment. It also allows you to free you up. Another thing you can do with this is you can pass your sheet around and have them, each student, record their data at whatever number. And like I said, you keep doing it until you start getting either all of the M's are gone or there's none left on your plate. Yes, ma'am?
The second time, where do we record our answer?
See where it says 2? Yeah, you're going down, you're going straight down. See, I've got 25 down here. Right. So this is the first column. Like I said, I put 100 on there because statistically it's possible that only one show up with an M. So you remove one and assume one at a time. So it's better to make it too big than too little. And I have done this and not given the kids the chart, but if you're working with freshmen or 8th graders or whatever, and this is their first time, then you want to give them the chart so that they do know what they're doing, or they can see it. Depends on how much time you want to do this. Number 3. Okay. If you're starting to get the same number, your fermentation process is done. I mean, if you can try it 1 or 2 more times. Yeah, All right, so I'm going to need some data. So holler out what we get for 4. 13, 18, 12, 22. Okay, since I had a 17, I'm going to use the 14. How about that? Did we get to 5? Okay. 12s, 9, 12s, 10, 18. Since I used 14, I'm going to go 12. Do we get to 6? 10, 7, 7. So I'm going to try 8. I'm just kind of randomizing my data. It won't be perfect because it's not a true sample. Do we get to 7? 7. I'm going to go 7, 7 here. How about, did we get to 8?
15.
I'm going to go down to 5 then. Remember, I'm making mine up. I'm doing it just to model. How about 9?
12.
You still had a lot. Are you out yet? When did yours die out? Because you
All of
had
mine were 9.
just
I
started
got
9.
9. I got 3 9s, and none of them had M's on them.
Okay, so you died out real quick. Okay. So we got to 9 for some of us.
I'm down to 3 on
I had 12, but then I had 12 without M's.
Yeah, so we have a 3. Okay. Anybody get to 10? It's kind of already repeated. That's good to know because, like I said, I had to assume that it might be a 1-to-1 match. All right, how familiar are you with this? Good, bad, indifferent? Okay, we're good. Honey, I can talk you through anything, I promise. All right, so we do know where the on button is, right? This is no lie, I have freshmen, they can figure out how to turn it on, and the only way they know to turn it off is let it sit there. Yes, Tony, and they took the ACT to get into college. I'm not kidding. All right, so in case, and I know y'all had Tammy and Dr. Martin yesterday, and they're more advanced than this, but this is home screen, so we turned it on, we're on home screen. Analyze your keyboard for the moment and find the word S-T-A-T, stat. So we are doing statistics to model this, and you want to go Can y'all see my screen? Okay, so we want to go to edit. Now, I've got garbage in here. Do you have garbage in yours? Listen to me and listen carefully. If you have garbage, arrow up to where it's on L1 or L2. Hit the clear key. For God's sakes, don't hit delete. And come back down. There is no delete in a stat editor stuff. All right, so in L1, put the numbers. We got to start at 0. And so it'd be 0, and in this case, 1 through 9. Now, I have 1 through 9. Some of you, if it started repeating at number 6 or number 8, once it repeats, put the repeater in there and then let it stop. Does that make sense? It needs a 0 in there. And it's important to know about the 0 because that's the initial time 0. Sometimes you can start at time 1, but when you start at time 1, and especially if this was a growth function instead of a decay function, then you need to know that y-intercept. You need to know what was your initial amount. Okay, so I will get mine in here. All right, some of you have already done this. Okay, I'm sorry, I went where I shouldn't have. You got your data in here. Some of you don't know what you're doing. You got to do second mode, which is the quit command. You got to do second mode to get out of the editor. The stat function's a little weird, and if you ever get anywhere on that calculator and you don't know where you're supposed to be and what you're doing, do second quit. It brings you back to home screen. Now, we want to do second y equals. This is going to take you into the stat plot menu. Some of you are there. Some of you haven't been there. Everybody there? All right. Hit enter right here on number 1, and we want to turn it on. And there are 6 different types. The first one is a true scatter plot, just a plot of dots. There's a line graph, a histogram, 2 types of box and whiskers, and that last one over there is what's called a normality plot. It looks like a step function, but it's a normality plot. Now, this should be L1, mine's not, so I've got to do second number 1 and second number 2. It should default, should be L1 and L2 for you already, right? If not, make sure that's there. You can do it any color, and I'm kind of short-sighted, so I like granny dot, the big one where I can see it. Then there's mama dot and baby dot. If you like baby dot, you can use it, but I can't see it, so I'm going to use granny dot. Now, go to the zoom key. Don't let me leave you in the weeds. Go to the zoom key. And when I said a few years ago, zoom stat, my kids would hit the zoom button and then the stat button. No. There is a command on your calculator that says zoom stat. And we got to go to the adult functions down here, down below. So we want to go down to number 9 and see it arrows down, so there's more in the back room. There's lots more. We don't want to go there. We just want to find the word zoom stat. Zoom stat, it's number 9. A lot of times, if you've worked with your kids quite a bit, you can tell them go to number 9, and they'll know. Go zoom 9. That was another time I was ready to kill a class. It was bad. Now, what this does is it fixes your window for you, and you hit enter, or excuse me, hit graph, and it's going to fix your window size, and it's supposed to plot the dots. Why did it not plot my dots?
You didn't hit graph.
But I did. There it is. Okay, yours may not look like mine, but it should have the general sloping shape, right? Yesterday, I think with Dr. Martin, you guys did a little bit of linear regression, right? Straight line. You realize that straight and line shouldn't be used together. When you say straight, it's automatically a line. But all right, so we're going to pretend right now that we don't know exactly what this models. So I'm going to walk you through, and there's first thing is it says make a rough sketch here. So I left it big, and this just gives you an idea. I'm not asking you to be perfect. okay? It doesn't have to be perfect. And don't expect your kids to be perfect either. Just a thumbnail rough sketch so that they have an idea of, hey, this what the data looks like. And if you want to really do it with graph paper, that's up to you. Okay. So we're on the page 3. We're into part 3. And the first thing we're going to do, calculate linear regression, hit enter. Everybody's got the new calculators. The good thing about the new ones is it defaults, L1, L2. But I want you to come down here where it says store regression equation. Did y'all do this yesterday? No. Okay, well, honey, you're going to learn it today. I want to be able to not only let the calculator write my regression, I want to be able to store it. Otherwise, it's on home screen and I can't do anything with it. So we're going to go to, there is a key on your calculator that says VARS, V-A-R-S. Do you find it? Go to VARS. Arrow over to the word YVARS. You are writing a function, so hit enter. And you want to store it in Y1. And so hit enter. What it will do now is not only put it in slope-intercept form and it'll show it on home screen, it's going to put it over there in the storage for us to use and play with. Now, come down and hit calculate. Is everybody here? Because this is where I'm seeing some squinty faces. Are you okay?
Your L1 is also L1.
Ah, please, thank you. Yeah, there's no telling. Since I used this last to teach stats, sometimes they flip it and put the first variable in the second, so you have to flip it, so I had it flipped for that. That's my excuse, I'm sticking with it, but thank you for catching it. Now hit calculate. Okay, now this screen tells us a lot. I don't know how far Mary and Tammy went yesterday. It is negative. It's going down, right? But this R tells you how good a fit you are. Do you think that's a great fit? 86%? Well, honey, we're going to get better. Ah, okay. I know why. Okay. It's no, go to second 0. You are now in the catalog function. Go on down to the words or arrow down to the D's, whichever way you want to find the word diagnostic on. If you've had to reset your calculators, then yes, this won't be there. Just second 0 and then go down to the D's till you find diagnostics on. Got it? Hit enter and hit enter and it's going to say done. Once it says done, done what? We don't know yet, but you'll see in a minute. Now, if you hit second enter a couple of times, it comes back and tells you this. L1, comma, L2, comma, Y1. Just hit second enter and bring this up. And now hit it again, hit enter one more time. Now you've got the R. This is when you turn on the statistical package. And that R tells you how good a fit you got. So, okay, 86% is what you can think of it. So, yeah, it's pretty good, Tony, I will agree. But it's not great. Now, that store key, if you go straight to Y equals, okay, right here it says record this, Y equals, so, and I asked for 2 decimal places, so we're going to have to do some rounding. So I have like 0.03x, and I'm going to have to arrow over. I know you can't see that. You will find the X, since it's AX, you will find the X at the end of your number, and then I've got plus 68.26. So here you've covered another skill. You're teaching them rounding skills. Yours won't be the same as mine. Hit graph this time. You're here, just go straight to graph. All right. This is why it's not the best fit. So one of the things you might want to do with students starting in 8th grade, because you can do this with 7th and 8th graders, you can just hit graph. Once you're in the y equals, go straight to graph. You can start talking about best fit. Does this data, is it best modeled by a line? How many dots did it hit? Any of them? One or two? What about yours?
Mine hit 1.
One, maybe? So this is not good. So there was a little space there. It says draw your thumbnail. So here's our thumbnail. Just roughly draw your dots. And oh, here it went like that. I'm sorry, I'm coming back out. And we know that our R was equal to 86. And then there's some questions here. We're going to say no, not best. How well does it fit? Not good. You know, you could ask them to write a whole paragraph at this point. I will ask this, Tony, how much time do I have now that I was late? I'm good? All right, I'm just asking. Okay. Return to the y equals function, because we're not going to get rid of anything. We're just going to restore some stuff. And it says turn this off. So bring your cursor to where it's flashing on the equal sign. We don't want to get rid of this. And hit the enter key. And hit the enter key. Because we want this to stay here. Okay. Noticed when you arrow off, your equal is now white or non-highlighted. Okay? We don't want to erase this yet. Yours didn't do it? You want it white. Okay. All this does is it allows you to keep the model in here for later exploration. All right, so some smart cookie is going to say that, and I'm going back to here, if it's not a straight line, what are other options that it might be?
Exponential decay.
Oh, we're not going there yet.
Sorry. It's the algebra teacher.
I know. Okay, algebra teacher, honey, back up.
A curve.
Okay, what kind of curve?
A downward curve. A parabola? A circular curve?
That's the one they'll know.
Okay.
Because you haven't introduced exponential yet, but you have done linear, and typically the next thing you do is quadratic, so a lot of kids will say a parabola or a parabola. So if you go back to your stat and calculate, and we still want, this time we want a quadratic regression, quadreg. Go back to stat, calculate, and go down to number 5 for quadreg. This time in the semester, the kids probably know that. Hit enter. If you have the new calculators, it's going to automatically pull up L1 and L2. Again, we want to go to store reg. If your student did that, if they hit enter, and it pops up on home screen, remember telling you about it, it would default? And the older calculators do not do this. You simply hit, did you hit second already? Do second number 1 and hit the comma key. Sorry, I need to go back. Second number 1, comma key. Second number 2, comma key. And especially the older calculators, if you have those, and that's what the paper is written for, is the older ones, then you go vars, y vars, function, y1. It does the same thing. Yours will have the same thing in a minute. Don't hit enter yet. I'm giving it back to you. Don't hit enter yet. It will have the same thing. So the directions are written for older calculators. And every year, mine is only 3 years old and they've already updated the system on it. So now I'm having to relearn another system. I'm not kidding. And it's really hard. I don't know about y'all's classes because maybe you have a set of calculators the kids can use. No such thing here. I've got kids coming in with everything from 81s to Inspires. And I don't know anything about the Inspire. Go down to store reg. Everybody with me? We're down to store reg. Again, hit vars, y vars, function, y2. We do not want to overwrite our first equation that made the line. We want to store it in the second box. All right, now I'm going to do it. Don't do it yet. You can did you see that? I'm going to pull it back up. Second enter. Don't do it yet. Those of you that were waiting, the calculator does it for you now. If you have the older calculators, you do it second number 1, comma, second number 2, comma, vars, y vars function, y1. And honey, you'll spit it out and can do it so fast, eventually you're like, the kids are like, and I'm like, I've been doing it for 30 years, people, come on. It did come out in 1981. I think I've had a good while to learn this. So now, everybody, regardless of where you're at, you hit enter. And your screen should tell you a little bit more. And it tells you that it is a quadratic regression, not a linear. So you have ax squared plus bx plus c. So our a minus 1.4, our b would be negative 2.70x plus a constant, a variation of 88. How good a fit have I got now? Got better. All right, so now if you go to your y equals, and in our y equals, we're down here. So it asks us to, probably on the next page, we want to write it right here. Everybody see where I'm at? No? It's about a little bit down. Didn't graph it yet. So now I've got 1.49x squared. This is also a good, like I said, if you are the Algebra 1 teacher, you could say plus the negative, or you can simply say negative 22.71x. It's a good review of stuff they've already seen before you introduce something they haven't. Plus, in my case, 88 point, looks like 70. If you are an 8th grade algebra teacher, this also reviews them for a lot of their basic skills. Rounding, estimation, things like that. So everybody's got a quadratic, right? So now do zoom, let's just go to graph. And here's your lovely quadratic. But what does a quadratic do that our data didn't? Algebra teacher.
It gives us a curve. As opposed
Yeah, it curves back up.
Yeah, well, that's an issue.
Can you see how
Yeah,
toward
that's
the
an
end
issue.
it's going back up on the other side? Our data didn't do that, right? It died out. So we know that's not the model, or we hope that's not the model. Again, thumbnail sketch here, just kind of rough. And our curve is coming down, but it's going back up. So we know that's not the best. It's going back up. It's not flattening out. It didn't die. It didn't decay. So I'm not gonna answer this one. I'm gonna ask you guys for some opinions. What do you think about this model? Now you remember it was what was our R for this one, 90-something? Well, actually it's an R squared because it's quadratic. I don't want to get into that. It was what, 90, yeah, 94, I think. 93, 94, somewhere in there, because it's 93 point something. So what's your opinion with this model?
We're getting there.
We're getting there, but still not the best, right? Will we ever hit it 100%?
No.
Why not? She's gonna jump in my box. I'm gonna ask her a question.
Because our data is, our equation is representative of the data. It is not an exact thing of the data.
Simple, random sample. Add that to your repertoire. SRS, simple random sample. This is a simple random sample that is representative of the data, and your sample is different from everybody else's, so they're not going to be perfect, okay? The only time that you will get a perfect one on these is if the data is canned data from a book. And that's why I like to do things like this, because they realize, hey, it can be something else. So how well does it fit? We know that the R squared is about 94. I think somebody had 98. You know, it's still a good fit, but a quadratic curves back up and ours doesn't. Okay, so y'all can decide how much of that you want to put in. Okay, smarty. Miss Catherine, right? Catherine or Kathleen? Catherine? All right, Catherine. Tell me what to do. I got to go to stat. I got to go to calculate.
Go down to 0.
Go down to the 0, EXP regression. Notice it's in the adult functions. It's not showing. Keep arrowing down. It's in the back room. Back in the day, that's where the adult videos were kept, was back in the back room. That's another colloquialism. An exponential regression, again, L1 and L2 are there. If you don't double bounce, you come straight down to store reg. Where are we going to put it this time?
Y3.
Y3. So vars, y-vars function, y3. Like I said, this is an excellent review. If you've done linear and quadratic and you're getting into exponentials, this is an excellent review for them to manipulate their calculator. So we're going to go on and calculate. Now how good a fit do we have? We're looking back at the R again, not the R squared, but the R again. What did we get this time? 99? 94?
I got
98.5.
98.5, so virtually 99. Okay, so we're talking, it's as good as it's going to get, and it be a simple random sample. Now, if 96, that's still good. If we go to y equal, turn off our second one by just being on the equal and turning it white. But we want to look at the R3 this time, because this one I have to think about how to write it. Second enter, I'm going to bring this back up. I have to look at this in order to write my equation this time. So notice the calculator is going to say A times B to the X. So our A is 80.02 for me. What's the matter? What's the matter? Let me get this written, then I'll come back. Raised to the X.
0.72 to the X power.
Yeah, thank you. I'll get it there in a minute. Now, we got it in there, right? We're at Y3. Just hit graph. How many dots did you go through this time? Several, yeah. And remember, we had almost a 99% R. So like how well is the fit? R was equal to like approximately 99%. And if you zoom out, just for fun, just hit zoom out. And that's too far out, Teresa. But anyway, if you look, it goes on and on and on and on. Another thing that you can do with the kids is you can go to second graph and look at the table. We had data that went out to what? I've lost my paper. 9 or 10? Yeah. How far do you go before that turns to 0? Hush. How far out do you have to go before it turns to 0? What do you think? Hush. I noticed. How far do you think I would have to go before this turns to zero? This output over here turns to zero. Now here's another thing that'll freak the kids out too. What does that mean? You can help me now.
Scientific notation.
Scientific notation. And if you arrow over there, it will show it. How far out do you have to go before it becomes zero? It's okay to be wrong. Say it again.
It doesn't become zero.
Absolutely. It's asymptotic. It never becomes zero. It will never completely die. That's why when you hit that point where it started to repeat, and like I asked Tony, that's when you would skim all the stuff off and say, this is as good as the wine's going to get, or this is as good as the vinegar's going to get. You know, I mean, you're done. This is as good as it's going to get. Now, then they put it in bottles and stuff, and you have to turn the bottles. If it's wine, ever so often, you got to go down there and turn them, you know, to make the scum that's left in there, to make it start, it'll settle, and you don't want it to completely settle, so you turn the bottle, like, I think it's 90 degrees ever so many days, so that it mixes it up a little bit. I know a little bit about winemaking, not a lot. I can't say I'm a wine drinker either, but don't tell Tony, okay? And I'm definitely not in the beers, okay? You know that taste he said you had to acquire, it didn't happen. Okay, so of the three, this is why we didn't erase them. If you want to convince your students, go back to your y equals screen and turn them all on. Turn on, just go over to the equal sign and hit the enter till it turns it black. And then you can hit graph, and Teresa messed up. It's okay. You can do zoom stat when it quits making a mess. Here's a good example of why quadratic didn't work, because look where the quadratic went. So I'm going to go zoom none. Now this shows you that of the three models, the best fit has to be quadratic. Exponential decay. Now I did exponential decay because we were doing it for Tony. Most of the ones that you introduce, I think that's pretty much the whole thing, ladies. But I do want to talk a little more since Tony walked out of the room. I'll wait till he gets back because I don't know what comes next. Okay, this is one, and you're welcome to reproduce it. It's not copyrighted. It's from a book that I use. I've used it with 7th grade. I've used it with my 8th grade, my advanced geometry students. I use it with my college kids. This one gives you more about the half-life of radioactive isotopes. It's kind of word problems kind of thing. So you have that. Now, the one question I did ask on the handout was, would you have gotten something different if you had removed the blank ones instead of the M's? What do you think? If you were removing the blank, would it have changed the outcome? I don't think so either. Okay, but we know about decay now. What's the other thing that we can have?
Growth.
Growth. Well, I'm going to tell y'all a short, long story. Anybody teach 7th graders? Used to. You ever had those giggly girls in 7th grade? Yes? Okay. And if you know anything about giggly girls in 7th grade, if they hear something, they got to repeat it, right? I'm setting something up and trying to think at the same time. That's not smart. All right. And since I know it's getting on toward lunchtime here, I think this one would be a good one. All right, so I've set something up for you. Till Tony gets back, we're going to play. Okay. Lovely, giggly girls. Something happened at home. The first thing you do when you get on the bus is what? You got to do what?
Talk.
You got to talk. You got to tell your best friend. All right. So time 0 get on the bus. You knew when you got on the bus. When you get off the bus, now my commute on the bus as a kid was an hour, so I get to use one. An hour later, 2 people knew. Well, honey, the story's good, right? Y'all know it's got to be good. So what's going to happen? Each person's going to tell somebody else, right? Because you typically have more than one friend. So 2 hours later, 4 people know. What time did y'all get here this morning? 9, okay. All right, so 3 hours later, when I was teaching school, we had to get there at 7 o'clock. So 7, 8, 9, 10. 3 hours into the school day, 8 people know. Still not too bad, right? 4 hours into the school day, 16 people know. Now that was probably about half of my homeroom. And you said you taught special ed. You know they're going to talk too, so, 5 hours later, in my case, really close to lunchtime, my whole homeroom knew. I didn't know yet, but my homeroom did. 6 hours later, my homeroom knew, and the lady next door to me, her homeroom knew. We had 6 homerooms in this wing. Not quite. 7 hours later, okay, 4 of the 6 know. 8 hours later, getting on the bus headed home, not quite half the school, but the entire 7th and 8th grade know in my little school, because it was a little bitty school. Get off the bus 9 hours later. Now, the entire wing and the principal knows. Mama ain't home yet. You still got a while for Mama to get home. 10 hours later. My little school, the whole school knew. The janitor knew. Your mama's fixing to get a phone call. And my daddy always got home an hour after I did. So you knew Mama done said to me, wait till your daddy gets home. Everybody in the school knows. 11 hours later. Only started with one person telling one little rumor. What's going on here? How's it growing? Exponentially. Rumors grow exponentially. Now I'm going to tell you what the rumor was. And it didn't happen to me, but it happened to the lady that taught next door to me, and she was from Tupelo, Mississippi. And it was about 7 hours into the school day. And she comes in, and I was Miss Smith then. She comes in and she goes, Miss Smith, I need to address your class. I said, well, honey, have at it. You want my class? Have at it. So I'm stepped back. She's got this big coffee table book in her hand, and she said, I need to squelch a rumor that is going around. Because at 8 hours into the school day, she done been called into the principal's office. Because it had done made it down to him. Now, it didn't make it to me, because if you want to know if the rumor got around, you come ask me. If I didn't know it, it hadn't got around. If I knew it, you're in trouble. And she said, I just had to go down and talk to the principal, and I have been told that I have a book on pornography in my class.
On what?
Pornography. Now, honey, I told you she was from Tupelo. Did I not start that out in the right dialect? Okay. So it was pornography. I'm like, okay. I'm sitting back here going, what in the... And she opens the book. Now, first off, she's got the title showing, Art History. Now, tell me, ladies, what was in that book? Michelangelo's.
Venus de Milo.
There you go.
Oh, David.
Michelangelo's David, Venus de Milo, and she opens to the centerfold, which was the Sistine Chapel. That was pornography. Well, I got the reputation of being the best math teacher in the building at that point, because when I said, Miss Paula, I said, we need to have a math lesson right here, and we need to talk about rumors. By the end of the day, everybody in the school knew about the book, but they also knew that I had turned it into a math lesson. And I don't even want to talk about, now all I did, what you couldn't see if you know about the ask function, I just put 2 to the x. Okay, maybe y'all do Facebook, I don't know, I don't. If you find me on Facebook, it ain't me. It's somebody else, but honey, it ain't me. I don't do any of that stuff. I'm just not a social butterfly. Okay, so how many friends do you have on Facebook? Just an average number.
500.
Oh, God. I knew Catherine would be the social butterfly. I can't use 500. That would grow.
Let's go with 80.
80. All right. This is why so many teenagers nowadays are taking their own lives. Whoops, I'm sorry. I hit the button. Somebody put something out there on Facebook. Somebody put something. Y'all with me? Look how our curve went. And second graph. In 3 hours, look how many people could have repeated the rumor. And there used to be a song back when I was a kid that said, talk is cheap when the story is good. And then you wonder why young kids have emotional problems when things get put out there. So if nothing else, here's another lesson that you can put a little morality in your lesson to your students and base it on math. And you can prove mathematically, you know, how fast this thing can grow. In 4 hours, you know, just how quick bad news travels. And that's via the computer, 80 friends or 80 acquaintances, whatever you want to call them. And if it's a good story, it's going to go real quick. It's going to go viral. So how big is viral? Another thing they keep talking about, like influenza and pneumonia and the bird flu. So this is another practical example of this, is like one person gets it. A few years ago, the kids out in California got the, what was it, mumps or measles. One kid came to Disneyland with the measles, and then it just spread like wildfire. Yeah, so this is how germs grow. You don't wash your hands during flu season. Look how many people you could infect. If there were 80 people in your 8th grade or whatever. Okay, so I see Mr. Tony. I don't know what else to tell you. I hope you got something out of it. You can turn your calculators off. If you want to clear them, just to kind of refresh how to clear them, you can go to Stat and go to Edit, arrow up, hit Clear, and arrow back down. Never hit Delete when you're in the Stat menu, because it will do some awful things. In your Y equals, you can clear it out. Just go there. You do have to be off of the equal sign and hit the clear key. And to turn your stat plot off, you go back into the stat plots and then pull each one of them up. There is a quick way, but you can just pull the 3 up that we did and say turn them off. I think they're desperate for a potty break.
That may just be me.
No, it's... So I hope you enjoyed it. You're welcome to the M&Ms and the paper plates and all that stuff. So, you know.
Thank you.
Thank you for having me.